All right, section 3, slicing and dicing composite figures. The learning goals in this section are to decompose composite geometric figures into rectangles, parallelograms, and/or triangles to determine their areas. Solve real-world problems by decomposing shapes into triangles and rectangles. Key term here is kite. Okay. And so the connection is you guys have been learning how to get the area of triangles and rectangles and parallelograms and trapezoids and kites and knowing that, and now kites, and now we're trying to get these areas and put them together or subtract them to get more complex shapes. Okay. For the warm-up, we have the following. First, we have a parallelogram, and so the area of a parallelogram is going to be base times height. And so this is going to be 22 times 10 and 5/10 meters. 22 times 10.5 gives me an area of 231 meters squared. Popular! Next, we have a triangle. The area of a triangle is 1/2 of base times height. And for this one, it's going to be 11 for the base, 7 for the height, and then I could divide it by 2, or I can multiply it by 1/2 to get my answer. And when I take 11 divided by 2, same as multiplying it by 1/2, and multiplying that by 7, I would get an area of 38 and 5/10 centimeters squared. That's that answer. Last but not least, I have my trapezoid. For the trapezoid, I need to, the formula is 1/2 of base 1 plus base 2 times the height. Then for that, I take base 1, 65, plus 35, and I multiply that by 30. 65 plus 35 is going to be 100. So it'll be 1/2 times 100 times 30. I know half of 100 is 50, so 50 times 30, and then 50 times 30 is going to be 1500 yards squared. 1,500 yards squared is going to be the area of that trapezoid. Okay? And so this is decomposite figures for section 3. All right, so on this page, to calculate the total area of an oddly shaped region, one strategy is to divide the region into smaller familiar regions and then calculate the area of each familiar region. So 1, draw lines in each figure to divide the figure into smaller familiar shapes. Then name the familiar shapes that make up the total figure. And so, as we're working on this one, we want to make sure that we are thinking about making shapes that would make sense with what we have done so far. I think that's a parallelogram. Perhaps. But I want to try. I can't tell, so I can't tell if this bottom one's a parallelogram. There's a whole bunch of ways to do this, but we need to make sure that we are making this into parallelograms because we know how to find the area of the parallelograms. We need to make sure we're changing this into triangles so we know how to find the area of triangles. We want to make sure we are changing this into trapezoids because we know how to find the area of trapezoids. We want to make sure that we are changing this into rectangles because we know how to find the area of rectangles. And so as long as we are breaking these oddly shaped things into things that we do know how to find the area of, we would be able to find the area of the parts and then add it together. And so that's the idea behind composite figures, which we've talked about. Alrighty, here, activity 3.1, the area of a kite. A kite is a quadrilateral with two pairs of consecutive congruent sides where opposite sides are not congruent. Okay, so we talked about like consecutive is next to each other, so 1.7 and 1.7, they're next to each other, so they're congruent. And then this one's 4.1, 4.1, and they're next to each other, so they're congruent. So one pair of congruent sides, a second pair of congruent sides. They're consecutive because they're next to each other. Okay, congruent, same size, same shape. The opposite sides are not the same. So 1.7 and 4.1, 1.7 and 4.1, they're not the same. Okay, so here this guy says, so it can't just look like a kite. In mathematics, kite has a very specific definition. Okay, so a quadrilateral, four-sided figure with two pairs, one pair, two pairs, of consecutive next to, congruent, same distance or same length, where opposite sides are not congruent. Okay, so kind of tricky, but you kind of can recognize it pretty quickly. The area of a kite, like that of other quadrilaterals, can be determined by decomposing its shape into smaller, familiar shapes. So Mr. Graham sketched the kite shown. He asked his students to add a line segment that would divide the kite into two familiar figures. And so we have Molly's kite, and Molly's kite, Molly took it and divided it this way. And then James's kite, and James divided it this way. And in class, I believe it was Michaela told us, and we all kind of agreed that Molly's kite would probably make the most amount of sense for dividing it because it should be easier, because both of the triangles Molly made are congruent to each other. So this triangle is congruent to this triangle. It is the same shape and size as this triangle. And so if I'm finding the area, this should be easier. Whereas James's kite would be two different triangles. So it'll be harder to find the area of those. Okay? And so describe each student's strategy and identify any additional information you would need to calculate the area. Would you rather use Molly's or James's diagram to compute the area of the kite? Okay? So Molly split the kite lengthwise with a dotted line from A to C. Okay. James split the kite into two triangles vertically. Okay. For both of them, we would need to know the heights or the heights of the triangles. Okay. And as we talked about, we want Molly's diagram because it would be easier. Okay, so kites, composite figures, we can break it up into two triangles. This is something we have talked about in class. All right, so now we're looking at that kite a little bit further. Use the information given to calculate the area of the kite using both Molly's and James's strategies. So we have to use Molly's, how she broke it up, and then also James with how she broke it up. this person giving us a hint, we use capital letters to describe a line segment. The letters AC indicate the length of the line segment that goes from the point at A to the point at C. So I'm going to start with Molly's because she's my favorite. And for Molly, we know it's 1/2 of base times height for the triangle. And we're going to get triangle ABC first. So the whole ABC, so the top triangle. Okay. And so to do that, our base is going to be AC. And so up here, I look for AC, and I see that AC is going to be 5 centimeters. And then the height for the triangle ABC would be from the base to the opposite vertex, and that is B. And so if I look at BE is 1.25. So I take that and multiply it by 1.25. Okay. Now, use my calculator for sure. I could take 5 and divide it by 2. That's the same as multiplying 5 by 1/2. I could then multiply that by 1.25, and then that's going to equal the area of the top part. Now, what I have to do then is that many centimeters squared. All I got to do is multiply that by 2 because the other triangle, the bottom triangle, is exactly congruent to the top triangle. And so I multiply that by 2, and I get an area of the kite of 6.25 centimeters squared. Okay? And so, boom, found the area of the one triangle. Then I can just double it because the other triangle is congruent to it. Now, James had 2 triangles like this. He had A, B, D, so this triangle's first. And for this triangle, BD is the base. And so 1/2 and the base, and I look for BD, and it's 2.5. And then the height of this one is AE right here. So it's kind of like we turn this triangle around, so it's like this. And the base is BD, and then the height is perpendicular to that, and it's AE. And so now we look at AE, and AE is 1.1. Okay. Now, I take 2.5, I divide it by 2, and then I multiply that by 1.1 to get my area of that triangle, which is 1.375 centimeters squared. Now, I can't just double this one because the other one is completely different. So now I have to find the area of another triangle, and that next triangle is going to be BCD. BCD. So now I got to find this triangle right in here. And for this triangle, I would start with the base being BD again. So area is 1/2 of base times height. Area is 1/2 times BD, which is still 2.5. And then I times it by the height, which is EC, or CE, because it can go either way. And so CE is 3.9. Now I can take 2.5 times 3.9. Can divide that by 2. It's the same as multiplying it by 1/2. And then I get an area for that triangle of 4.875 centimeters squared. Now I have to take the 2 parts and add them together. So I add the 2 triangles together. So I have 1.375, 1 and 375,000 centimeters squared. And I add to that the other triangle, so triangle ABD. And then I add to the other triangle 4 and 855 thousandths centimeters squared, and that is triangle BCD. When I get them together, I get the whole kite area, and that is going to be 6 and 25 hundredths centimeters squared. And I do get the same, so that's telling me that I am probably correct on that. All right, whew. Which method do you prefer for question 2, Molly's or James? This is method. Molly's method. Why? Because once you figure out the area of one triangle, all you have to do is double it because the two triangles are congruent. It's ENT. Okay. And so that is how we find areas of kites. Now, we will now go through some different composite figures which we did together in class. And so these videos will be here again to go over again because they're very complicated problems. And so I showed the two hardest in class and we tried to work together on a group so you guys could try to figure out the other ones independently, but we'll also go through those then too. All right. So we have this really tricky problem right here. With this really tricky problem right here, we have the paint and it's covering, we want to paint the house, okay? There's two things for me to think about here. First thing is I want to break this up or decompose it into different parts. There's lag time between this and what I'm saying, so I apologize. When I look at this, I see a rectangle here, and I see that the rectangle is 18 feet by 9 feet. That's the dimensions of the rectangle. I would multiply those together because the formula for a rectangle is base times height or length times width. And this would be 162 feet squared. This other one I can't quite figure out, and so I would have to decompose it or break it up into two different shapes that I know how to make. And I would make a bigger rectangle and then a triangle. What I'm having trouble with is what this dimension is right here and what this dimension is right here. And for me to figure this out, I know that the whole thing is 50 feet. And so the whole thing is 50 feet. And from here to here, it's 18 feet. That means that the question mark dimension is going to be 50 feet minus the 18 feet. And that'll be the same for up here because this line and this line are parallel to each other. And then 50 minus 30, 50 minus 18 is going to equal 32 feet. And so this rectangle is 12 feet by 32 feet. And I would do the area of a rectangle is length times width. In this case, it would be 32 times 12. And 32 times 12 is going to give me 384 feet squared. Okay. Last but not least, we have the triangle up here. The area for a triangle is going to be 1/2 of base times height. The base here is that question mark. It'll be the same as the 32 feet, so this would be 32 feet. So it would be 1/2 times 32 for the base and times 10 for the height. When I multiply that together, 32 times 10 is 320. Half of 320 is 160. And so it'd be 160 feet squared. Okay. Now let's look at this. I didn't show much work here in this first one, so I didn't like this first rectangle. The second one, I showed more work here, and so that was better. And the third one, I showed more work here. If I was to show another human being this, they would be able to understand what I did for the triangle part much better. Now I would add all three of them up. And I get a total of 706 feet squared. Now, in the problem, it says, suppose a gallon of paint covers 400 square feet. How much paint would you need to paint the entire back of this house? Well, if I have 706 feet squared, my first gallon of paint would do 400 square feet, or feet squared. If I had a second gallon of paint, then I'd be able to do 800 feet squared. And so if I can only buy it in the gallons, I would want to buy 2 gallons of paint. And that is how I would solve this tricky problem. Thank you for watching. La 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 la. La 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 la. Oh no! Okay, here we go. It is time to do another problem. So I'm going to let you know from the beginning that this is not an easy thing. This is quite tricky, in fact. This is not, whoa. This is not the first time I have recorded this, okay? So remember, math is a thing where you have to keep on working. Life is a thing where you have to keep on working. The harder you work at something, the better you get eventually. Sometimes things that are hard at first become easy. So here is how I think about this problem. I'm going to start by making an outline around this diagram. So I'm making an outline around this floor plan, because that's what it would be considered. It's like a blueprint. And I'm going to make a rectangle around it because I'm going to notice something about the rectangle. I know that a rectangle is a parallelogram. Because it's a rectangle, the opposite sides are always the same length. Okay? Because of that, I can look and I can see, and I'll do this in green, that this part is 35 feet. Then this part right here is 10 feet. And since it's another rectangle, that means this part is 10 feet. And so it means 10 feet and 35 feet means this whole side is 45 feet. Okay? If this whole side is 45 feet, because it's a rectangle, that means this whole side is also 45 total feet. Now I need to look at what I have here. From here to here, we have 14 feet. Then right on the outside of this, we have 12 feet. That means that this section right here is going to be the 45 feet of the whole side minus the 14 feet and the 12 feet. Or that means this section right here is 45 minus 26. Or that means that this whole side right here, 25. Is it 19 feet? Did I do that right? 45 minus 26. 19 feet. Okay. We're almost there. We're getting close. Next, since this side, let's go this way now. We're going to go down. This is 5 feet here, from there to here. This from here to here is 10 feet. It says right here. This from here to here is 10 feet. So going this way, we have 5, 10, and 10, or this whole side is going to be 25 feet. That means that this whole side is going to be 25 feet. If we know that this is 8 feet, then that means that this part needs to be 25 minus 8, or 17 feet. So this part of the living room is 17 feet. All right. The question, which I failed to read one of these times that I've recorded this, I'll do it now. Suppose that carpeting costs $1.20 per square foot. How much would it cost to carpet every room in this house except the kitchen. That means we want to figure these all out, but we do not want to figure out the kitchen. So let's go through the ones I know. Dining room. The dining room is going to be 8 feet times 19 feet, length times width. And the dining room is going to be 152 feet squared. Next, I know the enclosed porch. This is telling me that it's 10 feet. This is telling me it's 10 feet. 10 feet times 10 feet is 100 feet squared. Next, super tricky one. Let's see what I can do. I know for the super tricky one that we could separate it like this. So we have the orange rectangle, and then we have the other one, which is going to now be the pink rectangle. Okay. First, pink rectangle is 12 feet by 10 feet because it says this is 10 feet. So the pink rectangle is 120 feet squared. The orange one, the super tricky one, all right, hear me out. Almost there. This whole thing is 14 feet. Up here is 10 feet. That means this little bitty part right here is 4 feet. Since that's 4 feet, and the rest of this is 12 feet, this dimension, this length is 16 feet. Next. Oh, man. This from here to here is 8 feet. This from here to here is 5 plus 10 or 15 feet. Since this is 15 feet and this is 8 feet, that means this has to be 7 more feet to get to the 15 feet. Oh. So 7 times 16 is 112 feet squared. To carpet every room except for the kitchen, I would have to take 100 feet for the enclosed porch, 152 feet for the dining room, 112 feet for part of the living room, and 120 feet for the rest of the living room. I would have to add those all together to get 484 feet squared. Now, that is all of the square footing, but I don't pay $1 for every square foot. I pay $1.20 for every square foot. So I take $1.20 and multiply it by the amount of square feet that I have. If I had 1 square foot, I would just pay $1.20. If I had 2 square feet, I'd pay $2.40. If I had 3, so it's a multiplication problem. So using my calculator, 484 feet times $1.20. And that is $580 nope, that doesn't make sense, and 80 cents. Remember, it's money, so I should label it, and I should make sure I go to the pennies place, even if it is 0. Ladies and gentlemen, this is a tough problem. Math and life requires you to keep working hard so you can get better. This was tough, tough, tough. It was a nice challenge. If you understood the problem better from the beginning, that is a victory. Small victories each day will get us better from where we started. Dun, dun, dun. Dun, dun, dun. Dun, 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 dun. All right, so these are tough problems, but we're just trying to get a really decent estimate, okay? And so estimate the area of France. And so France looks kind of like this right here. And so I need to decompose it into shapes that I can figure out the area of. And so if I look at this, I would want to kind of take certain things here. And so if I go from 12, 1, 2, 3, so that's 3 centimeters, and each centimeter here is 75 miles. And then from that, I am going to go and I am going to take this and I'm going to make it into this rectangle here. That's about 2 centimeters there for this, okay? And so I'm going to kind of do the same thing with the rest of this. And is it going to be perfect? I'm going to go to 2 here. And then I'm going to go to this. And then I made it so it's perpendicular here, and it's not perfect, but then we have a base of 2 for that triangle. And then we have a height of 4 for that triangle. All right. And then I think I would do another one here. Two, three, four. So this has a height of 4, another rectangle. This has a base of 3. And then I would do one more triangle here. And this has, let's go with a base of 3. And then from there, so this is a base of 3. And then I got to make a perpendicular line here. And that's going to be about 2. Okay? So I can now figure out the area of all the parts. 3 times 2 is an area of 6 centimeters squared. Okay? Then 4 times 2 times 1/2 would be an area of 4 centimeters squared. 3 times 4 is going to be 12 centimeters squared. 3 times 2 is 6 times 1/2 is 3 centimeters squared. So if I take all these parts, I would have 3 centimeters squared plus 12 centimeters squared plus 4 centimeters squared plus 6 centimeters squared. Add those all together and I get 25 centimeters squared. Okay. And so trying to break this up into shapes we can figure out the area of is the goal of this right here. Then the next thing, which would be super tricky, but if I'm going this way and this is 75, another 75, another 75, I could multiply each of these by 75, can multiply each of these by 75. And so 75 times 75 is going to be is going to be 140,625 miles squared. Okay, so if I convert it, that would be my estimate. I could have done it before, and then these would have been bigger. And so maybe that's what I should have done. And I'll try to do that for the next one. Okay, so I'm going to pause it now, and I will do that for the next one. We're just estimating, and the most important thing is we're trying to break down the country into shapes that we can find the area of. We're trying to slice it up and get composite figures from this. All right, so now we're going to try to estimate the area of Namibia. I always have trouble saying this one. So we're in Africa, and kind of the same as before. I'm going to do this a little bit differently. So as I work on math, I'm going to get better if I keep on working and keep on thinking. And so if I look at my scale here, it looks to be about 1 centimeter is 100 miles. And so if I look, I'm going to kind of make it's an estimate, so it doesn't have to be perfect. So I think I'm going to go to about here and here. And so that's going to be about 350 miles. And so I'm going to convert it right away to miles instead of keeping it in centimeters. Then it makes sense for this one to go right here and to make a nice rectangle. This rectangle will be just about 420 miles. Okay, and yours is, if you were able to do this, yours should definitely be different than ours or than mine because I mean, let's think about that. I can make this into any shapes that I want to. I'm trying to cover as much of Namibia. Sorry, I apologize. That I can, and I'm trying to estimate, so it's never going to be a correct answer. And so it's that many miles squared for that box. Okay. Then I think I would do the same thing here. And I would go to 5.5 here. And so that would be 550 miles on this. And then I would go on just about 3. So it'd be 300 miles there. And then I would go 550 again to make a nice rectangle because that's easier to figure out the area of. And then I'd come straight down to grab this part right here. And so this would be then 300 times 550 to give me 165,000 miles squared. Okay. Then I would see that we have this little part right here. I think I would do a 2.5 inches, so 250 miles, just a little bit. So maybe a half or 50 miles. I'll make that into a rectangle again because it's pretty easy for us to figure out. And so 250 times 50 would give me 12,500 square miles or miles squared. And then I could add those together, but I think I can do just a little bit better. So we see that we have all of this, but then there was two, like I almost want to take out these two triangles. And so I'm going to try to do that here. It's going to be an estimate, so I'm going to try to get a little closer with my estimate. And so for this one, if I go 1 inch for the base, or 1 centimeter, I'm sorry, so that would be 100 miles for the base. And then I went up, let's see here, 2.5 for the height. So right to there, that'd be 250 for the height. And I could connect them to make a triangle. All of that's ocean right there. And so the Atlantic. And so I want to take that out of there. And it's a triangle, so it would be 250 times 100. But then I have to divide it by 2 or times it by 1/2 because it's a triangle. And so this would be minus 12,500 miles squared. Okay. And then I could do the same thing with this rectangle here. I want to make my estimate a little bit better. So once again, I'm going to go to about 100 miles or 1 centimeter on the map. And then I'm going to go up about 4 centimeters on the map, or 400 miles on the map. Then I'm going to connect the 2 points to make a triangle. And that will take out this amount, which is pretty close to that. And 400 times 100 divided by 2, because it's a triangle, would be 20,000 miles squared that I would also want to subtract. So now that I think I've got a pretty accurate one, I would want to add together my the areas I figured out. And then we have 12,500. And so I'd figure out all those. And then I would have to subtract the ones that I took out, the orange ones. And that would be, and I added them together, so that would be 32,500. And that leaves me with an estimated area for Namibia of 292,000 miles squared. And so if I think about these two problems, I think I did a better job on the second one. I think what I did to get from square centimeters to square miles was confusing. And so I think I would probably go back to this one if I have more time, and I would change it and I would try to convert it right away into my miles using the key on the map. Okay. But these are some super tough questions to try to estimate the right way, but we want to keep practicing these super tough problems, because then they start getting a little bit easier as we get better and better at math. Hello and welcome back. Here's the next one that we're going to do. All right, so the figure shown is composed of a rectangle and four congruent, same size, same shape. I once had a class repeat this at least 150 times to see if they would memorize it. They did. Determine the area of the shaded region. Determine the area of the shaded region. So we don't want to know this part, but we do want to know the shaded part. So I want to make sure I'm reading the question the right way so I know what I'm getting. Okay? So for me, what I would do, and there's a couple of ways to attack this one. What I would do is I would find the area of the whole rectangle. And so the rectangle would be the base times the height, or the length times the width, same thing. And so the area of the rectangle would be 80 by 30, and the area of the rectangle would be 2,400 centimeters squared. Okay, so I know this whole stinking thing is 2,400 centimeters squared. Now, I need to get rid of the trapezoids. There are 4 of them. So if I find the area of one of them, I can just multiply by 4 to get all 4 of them. The 1, 2, the 3, the 4. Now, a couple of things. First, I know that this and this are the same because they're congruent, same size, same shape. So to get from here to here is half of 80 centimeters. So for the trapezoid, I say trapezoid so I spell it the right way. I look smarter when I spell things the right way, even if I'm not. But we all make mistakes in spelling. I digress. And ruh-roh. And so base 1, or the bigger base, is going to be half of 80, or 40 centimeters. Next, base 2, they give me right here, which is 22 centimeters. Next, the height of two trapezoids is 30. Since they're congruent, half of the height would be 15 centimeters. So for one trapezoid, the area is 1/2 of base 1 plus base 2 times the height. Or the area is 1/2 of 40 plus 22 times 15. Or if I calculate this out, I'm running out of room. I'll move you up. It's going to be half times 62 times 15. At this juncture, I'll use a calculator, and my calculator is going to hopefully tell me the answer. Come on, calculator. And so I would take 62. When I times something by half, it's the same as dividing it by 2. And then I would times that by 15. And so that is telling me that each trapezoid is 465 centimeters squared. So we now have 465 and 465 and 465 and 465, or times 4, which gives me 1,860. So I would take the rectangle, 2,400 centimeters squared for the rectangle, or whatever I just spelled. I would subtract the trapezoids, which all together would be 1,860 centimeters squared for all trapezoids. And then I'm left with the shaded part here, which is going to be, in this case, 540 centimeters squared. Let me double check. 2400 minus 1860 equals 540. Now, that is one way to do this problem. The other popular way to do this problem in the past has been to figure out the area of the triangles. And that is possible as well. I just wanted to show you this way. Yeah. Next problem. All right. So this one is related to the previous problem, so that makes it a little bit easier. We're dealing with a hexagon. What we need to remember with the hexagon is that when we split it in half, we get two trapezoids. Okay? Next, the figure is composed of a rectangle and a hexagon. The length of each side of the hexagon is 2 centimeters. Determine the area of the shaded region. Here is what I would do. 1, I would figure out the rectangle. That's going to be length times width or base times height, either is acceptable. That's going to be 4 times 3.5. Maybe that's confusing for multiplication with decimals. I'll put it like that. That also means multiplication. 4 times 3.5. And so the area of the whole rectangle is 14 centimeters squared. Now I'm going to figure out the trapezoid. First, base 1 is this whole thing right here. And so that is going to be 4 centimeters. Base 2 is going to be 2 centimeters. The height of the whole thing is 3.5. Half of 3.5, ooh, that's tricky. 3.5, whoa. 3.5 divided by 2, half is the same as dividing by 2. So the height is going to be 1.75 centimeters. Okay, so 1 trapezoid, 2 trapezoids. All right, area of a trapezoid, 1/2 base 1 plus base 2 times the height, or 1/2 of 4 plus 2 times the height. And then if I figure this out, let's see here, half times 6 times 1.75, or 3 times 1.75. And then we get 1.75 times 3 equals 5.25 centimeters squared. That is one of the trapezoid. The other trapezoid is 5.25 centimeters squared. So all together, if I add those together, I would get 10.5 centimeters squared. And so I would take my whole rectangle, minus my 2 trapezoids, and that is going to equal the shaded region, which is going to be 3.5 centimeters squared. Okay, and that is one way to solve this problem. There is, you could probably figure out the area of each of the triangles and either add them together or whatever to get that. So this is just one way to do that, and that is that. Ha 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 ha. Ha 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 ha. Ha ha ha. Bye. Later. See you. All right. So when I was first looking at this, I'm like, this shouldn't be that tough of a problem. And then I looked, I'm like, didn't it give us a couple things that does make it kind of a tough problem. Determine the area of the shaded triangle inside the square. Explain your strategy. So I need to figure out the triangle here, and I need to then somehow figure it out. But they don't give me the base of the triangle or the height of the triangle. So that means I'm going to have to figure out the whole thing and subtract away what I don't want to know. Okay. So first, I figure out the area of the square. So I figure out the area of the whole square. It's important for me to remember that it's a square, so that means all the sides are the same length. And the square is 10 inches by 10 inches, so area of a square would be length times width, or base times height. And for the square, the base and the height are the same, so it would be 10 times 10, or I could write that as 10 squared. Either way, it's going to be 100 inches squared. Okay, so for the whole thing in here, I know it's going to be 100 inches squared, so I know my answer has to be less than 100 inches squared. Okay. Next, I need to start taking away these triangles. And so to do that, I need to remember that this is a square. So this triangle has 10 as one of the sides, and then on the other side, it's going to be not 10. This is where it's tricky. This is 3. That means this has to be 7. And so for this orange triangle right here, I know that for the orange triangle right here, it would be a, let's see here, orange triangle. Then I know my area as a triangle is going to be 1/2 of the base times the height. I know for this triangle, I could consider either of these the base. So it's going to be 1/2 times 10 times 7. And then that's going to be 5 times 7, which is going to be 35 inches squared. Okay. And that's the orange triangle that I've made there. And I'd be taking that away from the area of the whole square. Next, I want to do the blue triangle I'm making here, and it looks to be just about congruent to the last orange triangle we did. And so it has one side length of 10, and so its area is going to be 1/2 of base times height, because it is still a triangle. And then it's going to be 1/2 of 10 times 7, and show that again. It's a square, so this is 10. It's a square, so this whole thing's 10, but this bottom part's 3. 10 minus 3 is going to give us 7 right there. Then it's going to be 35 inches squared, just like the last one. So it is congruent to the last one. Pick a color. Green. Now all I have left is this baby green triangle. So right there, right there, right there. And so 4, I figured out the area of the green triangle. And for this one, area is 1/2 of base times height. And in this one, area is 1/2 of 3 times 3. And when I calculate that out, I'm going to get 4.5 inches squared. Okay. Then, to get my answer, I would first take the square, then I would subtract the orange triangle, then I would subtract the blue triangle, and then I would subtract the green triangle, and all I'm left with is the shaded region. I could think of it this way. I could add up the orange triangle, blue triangle, green triangle first, and then I could subtract that from the whole square as well. So I have 100 minus 35, which will give me 65, minus 35, which will give me 30, minus 4.5, which should give me 25.5 inches squared. Okay. If I had to create a presentation, which no one asked about, I would have said, don't worry about it. Because what I would do is I would have a few slides. And I would have one slide. I'd do this as a slideshow. And the first slide would be the original thing. Then I would show just the 10 by 10 square and me figuring out the area for it. Then the next one, I would show the orange triangle and me figuring out the area for it. Then I would show the blue triangle and me figuring out the area of it. Then I would show the green triangle and me figuring out the area of it. And then I would show the final slide of me showing how I had the original area of the whole thing and me taking away the areas that are not shaded, so that all I'm left with at the very end is what is shaded. Okay, and that's what I would do in my presentation.